So, you or a loved one has been diagnosed with sickle cell disease. I'm sure you have 1,000 questions, like, how did this happen? What is sickle cell disease? What are some of the symptoms of sickle cell disease? And what treatment options are available? Well, we're here to help you, so let's talk about it. Sickle cell disease is a genetic condition that affects how red blood cells are made. Normally, red blood cells are circular or disc-shaped. This allows them to smoothly travel through your blood vessels without any type of issue. However, when a patient has sickle cell disease, their red blood cells change shape. They go from a normal round disc to something more akin to the sickle you may find on a farm. This change in shape is because the gene responsible for making red blood cells is slightly mutated, which causes it to make the wrong type of hemoglobin protein, a major component of a red blood cell. When the hemoglobin protein is made incorrectly, the red blood cell will change shape. Why is this an issue? This new type of red blood cell isn't smooth and is instead more or less shaped like a crescent moon or a croissant. Because it isn't smooth, unlike normal red blood cells, this new type of red blood cell, called a drepanocyte, can collide with the walls of the blood vessels, which makes them become stuck or trapped in the blood vessel. Now here's the bigger issue: pile-ups. When you're driving on the highway and the car in front of you gets into an accident, you want to immediately hit the brakes to avoid hitting the car in front of you and getting into a pile-up. Makes sense, right? But when a drepanocyte gets caught in an intersection between two blood vessels, or when it sticks to the wall of one blood vessel, other red blood cells can't hit their brakes. When you think about it, your heart is pushing the red blood cells in your blood vessels constantly, and your heart can't hit the brakes because that would be detrimental to your health. As a result, other traveling red blood cells crash into the stuck drepanocyte, resulting in a red blood cell pileup. This forms a blood clot, also known as a thrombus. Thrombi can form in virtually any blood vessel. Think about what blood vessels do. They transport blood to your tissues. You have tissues in every single part of your body, and therefore, sickle cell disease can impact different parts of your body by forming a thrombus in a blood vessel. When a thrombus forms, circulation in the blood vessel halts, just like when the highway patrol shuts down a major highway following an accident. Because of this, blood cannot reach its final destination, the tissues. And when tissues are without blood, they become injured and start to die in a process known as necrosis. As a result, the region of tissue that has been cut off from the blood supply may hurt tremendously. This is called a vaso-occlusive crisis, marked by a severe amount of main blocking blood flow to the blood vessels in the chest, abdomen, and joints. Additionally, thrombi can cause swelling in the hands and feet. When you think about it, your hands and feet are almost always at the lowest ends of your limbs. Therefore, in order to push blood out of your hands and feet, the heart has to work against gravity to move blood through your blood vessels and prevent the blood from pooling in these extremities. But when the blood vessels are blocked due to a traffic jam, then the blood cannot flow back up and will sink back down into the hands and feet. Another symptom that sickle cell anemia can cause is fatigue. Your brain is your mood and feeling powerhouse, and it needs a significant amount of oxygen in the blood in order to function. But when traffic jams prevent oxygenated blood from reaching your brain, you may get really sleepy, no matter how much rest you got the night before or how much coffee you drank in the morning. Without sufficient amounts of oxygen, you will become fatigued, making this another common symptom of sickle cell anemia. Lastly, One major symptom of sickle cell anemia is an increased risk of infection. You see, on your left side, near the end of your rib cage, you have an organ called the spleen. The spleen is responsible for getting rid of bad bacteria and pathogens that may be circulating in your blood when they aren't supposed to. So what's the issue? Well, traffic jams, again. The traffic jams in your blood vessels can damage the spleen, causing it to not work as well as it should. As a result, some bacteria and pathogens are able to slip past this crucial defense mechanism and remain present in your bloodstream. That sounds pretty grim, but not all hope is lost. Thankfully, many modern advancements have been able to help fight sickle cell anemia, reversing the effects of the altered gene. Sickle cell anemia can be cured through bone marrow transplants. By transplanting healthy stem cells, damaged cells are given the space to be replaced. The new transplanted cells will replicate to create healthy blood cells. Sometimes, though, transplants can cause immune reactions in the body. Scientists have been developing ways to cure sickle cells without doing any transplants at all, instead using a patient's own cells. Through a technology called CRISPR-Cas9, or just better known as CRISPR, doctors are able to alter the genetic makeup of a person's cells. By matching specific areas of DNA that can be used as locators, DNA can be snipped and replaced in specific locations, allowing for gene editing. CRISPR can be used to edit the DNA within your stem cells, fixing the mutation that causes sickle hemoglobin. After the mutation is fixed, the stem cell is reintroduced back into the body and can stop the production of drepanocytes all by itself. Healthy hemoglobin means healthy cells, and your blood and body thrives.